Now that you have read the free fall sections from the textbook and have been introduced to the equations that we use during free fall, I'm going to go through 3 different examples of how you solve free fall equations for different situations. I will solve how fast, how far, and how long. So when we are talking about how fast, I'm always talking about a velocity. So, as I read the question, in a bizarre but harmless accident, a watermelon fell from the top of the Eiffel Tower. How fast was the watermelon traveling when it hit the ground 7.8 seconds after falling? So I know 7.8 seconds, and I know that it fell from the top of the Eiffel Tower. So I know my time is 7.8 seconds. Now, when an object is falling, we know that it has an acceleration due to gravity of the planet that it's falling towards. So for Earth, anytime an object is falling or in free fall, the acceleration we use is 10 meters per second squared. So I know that the acceleration is 10 meters per second squared. So that means I'm trying to find velocity, which is what I was trying to find. How fast? So if it's falling from rest, they dropped it from the top, I'm trying to find my final velocity. So then I use the equation VF equals A times delta T plus VI. So that's going to be 10 meters per second times 7.8 seconds plus 0 meters per second squared. So that gives me a final velocity of 78 meters per second. Most of the time, if they do not tell you a starting velocity, you can assume that when you're dropping an object, you're dropping it from rest. So that's the assumption I made here. But that is how you would solve how fast. Example 2 is looking at how far. Anytime I'm solving for how far, I'm solving for delta x. So this problem says, use the information from example 1 to determine how high up the watermelon was when it began to fall. How high is very similar to when we're talking about how far. We're talking about a distance, a displacement, which is delta x. So the information from the previous problem was delta t equals 7.80 meters per second, just seconds. Acceleration was 10 because the object is falling, so acceleration is 10. I don't really need this information, but I can put it in there. My initial velocity is 0. So I'm trying to find delta x. So I'm going to use that same equation. Delta x equals 1/2 a times delta t squared. Now in the textbook, they use the equation d equals 1/2 gt squared. These two equations are very similar. They're telling you the same thing. The only difference is we use different symbols in our class than they do in the textbook. So I would like you to use this equation here. We're going to plug in our numbers. So we're going to plug in 1/2 times 10 times 7.8 squared. Now please make sure that you do the 7.8 squared part first. That is where our most common errors are for these types of problems. So I do 7.8 squared, then times 10 times 1/2. When I plug that into my calculator, I get 304.2 meters. Please remember, delta x is how far. It's a distance or a displacement. So that means my units are only distance, and my units for distance here are meters. The final example I'm going to show you is how long. Now remember, how long, I'm not talking about a distance, I'm talking about a time. So I'm looking for delta t here. So here's my problem. The climber dropped her compass at the end of her 240 meter climb. How long did it take to strike the bottom? So we know delta x, the distance, is 240 meters. She dropped it, so it's falling in the air, which tells me that my acceleration is 10 meters per second squared. I'm trying to find delta t. Now the only formula, we have two formulas that have delta t in them. I have A equals delta v over delta t, and delta x equals 1/2 a times delta t squared. So if I look at the information that I have, I'm going to see that this equation right here is the one that I want to use. So I'm going to start out with that equation. Now I want to solve for time. So I'm going to rearrange this problem, this equation, to solve for delta t. Usually I would make you rearrange the equation yourself, but for this one, since it's a little bit more complex, I'm going to go through it now, and then I will be giving you that delta t formula. So I want to get 2 on this side, so I'm going to have 2 times delta x equals a times delta t squared. I want to get delta t by itself, so I'm going to divide by a. So I have 2 times delta x over a equals delta t squared. To get rid of the squared, I'm going to take the square root. So my equation is going to be delta t equals the square root of 2 times delta x over a. So this is the actual equation that I will be using. I will give you that equation since it's a little bit more complex of a rearrangement. So make sure you have that on your paper boxed so you know that's the equation I'm going to give to you. So now let's start with that equation. Up at the top of the page. So delta t equals square root of 2 times delta x over a. So that equals 2 times 240 divided by 10. Please make sure you, when you put this into your calculator, you use parentheses carefully, or do the part in underneath the square root first, because if you do just 2 times 240 in the square root and then divide by 10, it will give you the wrong answer. So I would do 2 times 240, which gives me 480, divided by 10. So then I have this equals a square root of 48, which gives me an answer of 6.9 seconds. So now I have 2 ways I can find time, but it depends on which equation has the information that I need. Now I want you to turn to worksheet number 4 in your packet. Use the examples to help you complete the problems on that worksheet about free fall. Remember, when you are given a free fall problem, you have to assume the acceleration of the planet you are on. Assume that you are on planet Earth. unless otherwise stated.